Hello, friends, and welcome to Fun Facts with Miss Rhodes. Today we are talking about the periodic table of elements. Not the whole table, but instead we're just going to start getting familiar with how to read these fun little nuggets of information, the element squares. To begin, we'll look at hydrogen because hydrogen is ubiquitous. We find it in water, we find it in DNA, we find it in almost everything. So, hydrogen, if I'm looking at its square on the periodic table, I will notice first of all this big bold symbol. The atomic symbol is H. Anytime we see a singular capitalized H, we know that it is hydrogen we are talking about. It's like a name badge, okay? The next thing I notice is the number at the top of the square. The atomic number is very important because it will tell us the total number of protons and electrons in a neutral atom. So this means without a charge, and we can assume that when we're reading the periodic table, all of these atoms are existing in a happy neutral state. The third thing that I notice is this number, which is the atomic mass. Now this is going to look a little funny, 1.008. It's usually going to have decimals after it. It's usually going to be a pretty big confusing number, but that's okay because the mass is actually a very important piece of information telling us how many neutrons are in the atom. So for example, with hydrogen and the atomic number 1, I can begin by noting that it has 1 proton. So I'm going to draw that proton in my nucleus. There's my proton. And then I will notice too that the atomic number, being 1, means it also has 1 electron. There's my 1 electron on the ring outside of the nucleus. Stand by for a later video about what these rings mean and why the electrons exist in the way they do. Anyways, to determine the average number of neutrons, I now need to use this atomic mass. I'm going to round it to the nearest whole number and subtract from that the atomic number. So 1.008, we need to follow our rounding rules. Friends, follow me if you will, over here. 1.008. I'm going to look at this number next to the decimal, noting that this is a 0, so it's a 0. Doesn't really count. If it's 4 or below, let it go. If it's 5 or above, give it a shove. So this is a 0, it's 4 or below, we're just going to let it go. That means we're left with 1. We just rounded our atomic mass to 1. Now I'm going to follow my instructions where it says subtract the atomic number. 1 minus 1. That gives me 0. There are 0 neutrons usually in a hydrogen atom. And that's okay. So that means my diagram here is complete. My friends, not all of them can be as simple as hydrogen. Let me explain. Over here we have lithium. Lithium is one of my favorite elements. Lithium has an atomic number of 3. So therefore, it must have how many protons and electrons? If you said 3, you're right. 3 protons and 3 electrons. So go ahead and draw those. I'll put my protons in the middle. And I'll start putting my electrons around the outside in the rings. Ta-da! Am I done though? Is this now complete? It absolutely is not. We need our neutrons. So, let's go ahead and do that math, shall we? Stand by. There we go. Call that zooming in. All right. To figure out our number of neutrons, we need to take our mass, round it, and then subtract the number. So let's do that together. Follow me over here. Our mass of 6.94. Well, that seems a little complex. 6.94. We're going to start at the decimal and move over here. Remember, if it's 4 or below, let it go. But if it's 5 or above, give it a shove. 9. That's greater than 5. So we need to give this a shove. We're going to shove it up to 7. So we just rounded to the nearest whole number. That's 7. Now, I can take this new mass number of 7 and subtract the atomic number, 3, and that gives me 4. That means that in lithium, there is an average of 4 neutrons. Let me draw those. 1, 2, 3, 4. Now my lithium is complete. And you know what's really great, friends? This even works for the biggest atoms of them all. Potassium. It's not very large, but it is largely important, and it's one of the best macronutrients you can get for yourself, and we find it in bananas. So, potassium has an atomic number of 19. So here's my atomic number of 19. That means how many protons does it have? If you said 19 protons, you're right. 19 protons. Very good. And also, because the atomic number is 19, that means it has how many electrons? If you said 19, you are right again. Very good. And then lastly, we have to figure out that whole neutron thing, right? So remember, this is the part that's the trickiest, but once you got this down, you've got it made. So to find the number of neutrons, we need to take our mass that has been rounded. Ooh, it would help if I could spell. And then we need to subtract the number to get the average number of neutrons. Right? Average. Average being the key word here. So let's take that mass right there and follow me, if you will, right here. Okay? Our number is 39.09. That's our mass right now. With this mass, I'm going to start figuring out what I want to do with my digits. And in fact, I'm actually going to begin all the way over here. Look at 39.09. Remember, if it's 4 or below, let it go. If it's 5 or above, give it a shove. Well, in this case, I'm going to want to shove up to make this one 39.1. Okay. So now I have 39.1. With 39.1, I'm going to look at this decimal place now, right next to the decimal itself. If it's 4 or below, let it go. If it's 5 or above, give it a shove. I think I'm going to let this one go, my friends. Let it go. Be like Elsa, let it go. All right, so that leaves me with 39. That is my rounded value, 39. Now I need to take my mass, rounded, 39, minus the number, 19. 39 minus 19 is 20. That means that there is an average of 20 neutrons per potassium atom. All right, my friends, this has been a quick review of how to read and calculate from the elemental squares to figure out what those elements and atoms are actually made of. For more help, please be sure to come to Zoom, and I will see you soon. Have a good day.